Good evening, I'm Michael. I'm a doctoral student in agricultural engineering at the Federal University of Santa Maria, and I'm going to present a study called Kinetic Study of Supercritical Hydrolysis in Agricultural Biomasses under Ultrasonic Pretreatment. When we are considering to add value to residual biomasses or to break the lignocellulose-based wall of these materials, we're talking about the application of certain technology or technology integration. The current scientific literature explores this scenario with the application of important hydrothermal pretreatments. In this condition, the ultrasonic and supercritical water hydrolysis technology are main important once they are strategies with high efficiency and with cost effectiveness. However, there is a notable scientific scarcity when we're talking about the integration of these two alternatives. When talking about the ultrasonic technology, we are relating to the mechanical action generated by the formation of microbubbles in contact with the solution. These conditions will provide a degradation of lignin and disruption of rigid structures. On the other hand, when you are considering the subcritical water hydrolysis, we are considering high temperatures and high pressure. These conditions will provide a significant rupture of the lignocellulosic matrix and obtain the high yields of compounds of interest. Every year, high amounts of residual biomasses of many crops are jumped into the environment. These materials are generated from the harvest and industrial processing. When the literature um, search for the exploration of these materials, we're talking about three important points, which are the efficiency, the economic or energetic viability, and the sustainable approach. Accordingly, the aim of the study was to evaluate the effects of ultrasonic pretreatment on the yield of fermentable sugars from residual biomasses of rice, soybean, and pecan under subcritical water hydrolysis. According to the material and method section, the step 1 is related to the obtaining of biomasses, rice shell and straw, soybean shell and straw, and pecan shell and husk, and the drying, grinding, and storage conditions. The step 2 are related to the ultrasonic pretreatments in a reaction time of 15 and 60 minutes and energy density up to 37.6 joules. The step 3 is related to the supercritical water hydrolysis in a reaction time of 0.5 to 15 minutes, temperature of 220 degrees, and a flow rate of 10, 20, and 30 milliliters by minute. According to the results and discussion section, to the rice biomasses, where the figure A is related to the rice shells and the figure B are related to the rice straw, we can see the kinetic performance of these two biomasses, where the rice shells obtain the high yields near 14 grams by 100 grams biomass, with the best condition of 15 minutes and 2.7 joules. According to the rice straw, the best conditions near 12 grams by 100 grams of biomass were obtained with the conditions of 60 minutes and 5.5 joules. According to soybean biomasses, where figure C is related to the soybean shells and figure D is related to the soybean straw, the kinetic behavior, we can clearly see the low amounts of yields in the figure C by the soybean shells, where the high yield was obtained near 4 and 6 grams by 100 grams biomass in a condition of 15 minutes and 1.9 joules, and figure D with relating to the soybean straw, the highest condition of the yield, which were near 6 grams by 100 grams of biomass, were obtained in a condition of 15 minutes and 2.3 joules. Finally, for the pecan biomasses, where figure E is related to the pecan shells and figure F is related to the pecan husks, The highest yields of pecan shells were obtained in a condition of 60 minutes and 19.8 joules and 23 grams by 100 grams of biomass. And figure F, related to the soybean husks, the best condition was the condition of 60 minutes and 20.9 joules. So concluding, the analysis of the hydrolysis solutions showed a yield of up to 23.8 grams by 100 grams biomass for pecan shells under the pre-treatment conditions of 60 minutes and 19.8 joules. And the integration of pretreatment technologies associated with supercritical technology is a promising alternative for the approach of recycling and adding value to agricultural residues under the concepts of biorefinery. The references. Thank you very much.